Hello guys, and welcome to this new video on our OpenGL series. Hope you guys are doing good. The previous video was about a short introduction of what OpenGL is. If you're watching this video for the first time, I will recommend you to go and check the first video on this series. I always provide the link for the playlist in the description below. You can go and check that out. Now in this video, we're going to be moving forward and learn how to create windows in OpenGL. And for that, we will need to install or link some couple of libraries that are really important. There is no way of creating windows using OpenGL. That's why we need some external libraries that have been made that will actually help us create a window and a context for OpenGL to operate on. So that's basically the idea of this video. My plan is to upload a video each week. So if you guys don't want to miss any of my video, make sure you hit the subscribe button, like this video, and share if you have to. Let's get started. The first thing I want you to do in this video is to create an empty project. Now I'm gonna be using Visual Studio for my project, so you guys can use whatever IDE you want. If you even already have like OpenGL, Glue, and GLFW installed, then you're good to go. But for those of you who really want to follow and do the same thing that I'm gonna be doing, I will recommend you to install Visual Studio. Now I won't show you how to do that. You simply have to download the Visual Studio installer and you will choose the C++ library for that, and you'll be good to go. So there are thousands of videos out there about that. If you have any problem, just let me know. Now it's important to add this CPP file because the things we're going to be doing in a couple of seconds required from you to have a CPP file created. So that's why I make sure you have this file created. Now, as I said a couple of minutes ago, OpenGL does not provide a way of creating windows on any platform. So we need like a library to actually be able to do that. And the one we've chosen is GLFW. You could also use like SDL, and I don't know, there's a lot more you can use. I think SFML also does the job, but yeah, GLFW it's really lightweight, and yeah, it's really easy to use, so why not use it? That means you need to download and have GLFW on your computer before we move forward. I will provide the link in the description below where you can download GLFW. So you simply come in this page right here and you download this version right here. As you can see, we have this C++ 2010 Visual Studio version, which is the 32-bit, but we don't want to use that. We're going to be going with this one, which has everything from 2010 till 19. So download the 64-bit. You should normally come with a zip file like this, and you just have to unzip it, and inside of that zip file you will find all kind of version of GLFW according to the IDE you're using. So if you're using CodeBlock, this one will be the one to use because CodeBlock works with main GW compilers and things like that. So if you're using Visual Studio 2017, you will go with this version, and so go on. So since I'm using the 2019, so I'm going to be picking this one. Now I want you to copy this include folder, then so I'll simply go and copy, and you need to go on your project and open folder in File Explorer, and there you can see I created a folder and I call it libraries. You could call it dependencies, libs, whatever, it doesn't matter. And in there I create another folder called GLFW, in which I just paste my two folders. And as you can see, I remove the other files because I didn't need them. So let me go and show you. So if I open this folder right here, you will see we have this DLL file, which can also be used to link dynamic link and things like that, but we don't need that. You see, we want to link statically. This one is for static linking. That's why I took this one right here. I removed both of these because I didn't need them, and I don't want my code to to have data that I don't use. So that's basically the part where you download and put it in your project. Now the second part is to actually link that to Visual Studio in our project so that he can use GLFW to actually create a window for us or anything like that. So you want to click on this and say properties, and here you want to go on C++ here, and you go on general. So we want to add our includes file. So if you don't know how or what means static linking, dynamic linking, let me know in the comment section below. Maybe I'll talk about that, but I think you probably know that, so I don't want to spend time on that. So now there is two ways of actually making this. I could use a relative path. Relative path actually refers to the fact that GLFW will be relative to this project. So if I move this project and give it to someone, he won't have to install GLFW again. But if I do this with absolute path, then anyone I gave this code to will have to make sure he changed the path to GLFW, and I don't know any one of you who want to do that. So we're gonna be doing it with relative path. Now, how can we do that since we don't have a way to know what is the name of the directory of our project, because the directory of your project is different from mine. Visual Studio actually offers a way of dealing with that kind of thing by using some operators. I want to browse and change that because I don't want to be writing things my own. So go to include, and I have this. So I simply want to go out. You see, this is absolute path. If I leave it like this, and if I give you the source code of this project, you won't be able to access, you won't be able to use GLFW because this path is not the same thing on your computer. That's why I'll simply go out and remove this and paste this solution dir, and you can see the path down here. This is the value, evaluated value. You can see the value is still the same. So depending on your computer, you will always have the right path for GLFW. So that's the first thing to do. Now you want to go down to linker, you want to go to general, you want to go here to additional library directories. We also want to add the lib folder, so you want to browse right here. So go in your project, you want to say libraries GLFW lib, and you want to say select folder, and you want to change this again with what we have. So, and you can see we still have the right path down. Now we also need to add something to the input right here. So we want to add everything we need. I won't write each one. I will simply go and paste them. You can see right here, the glfw.lib is the file that I showed you before. This one right here, we need to actually link that library file. You know, we also want to be linking on OpenGL because we're going to be using OpenGL. And these are some inherited libraries that you don't have to care about. So I just wanted to remove others because we didn't really have to use that, because Visual Studio actually add a lot of libraries which we don't actually use, and so I just wanted to remove them just to make sure we don't use that. That should be normally everything we have to link. So apply, and you say okay. Now you can simply go up here and say include, and you say GLFW, and then you can include this one. So that's basically it. We now have GLF installed on our computer. Now we want to move and start creating our window. The first thing I want to do before we start doing that is to define two constants right here, like screen width. It's going to be 800, and I want to do the same thing for the height. So this one is going to be 600. So in order for us to create a Windows using GLFW, we need to initialize it first. So let's go and initialize it by just calling the init function. Now the next step, we want to set some couple of hints or properties or attribute or whatever you want to call them, because these are really important. We're going to be watching them step by step. Now the first thing we're going to be talking about here is the context version, the minimal version, I want to say like that. So if you have like the version 3.4, 3.5, 3.3, 4.2 or whatever, they should work, but you want to specify the last version that you want to use for your project. Since my computer has the 3.1, that's why I go out and add this. Now we also talked about things like core profile in the previous video and things like that. I just don't want you guys to be confused about the core profiles and compatibility profile. I'm coming back to the code in a couple of seconds. Now since the version 3.0 of OpenGL, the concept of deprecation was introduced. The idea was simply to remove all functionalities of OpenGL. So the 3.1 is the version where we officially have the core profile normally. We also have another way, which is the compatibility profile. In this one, you simply have the core profile plus the deprecated functionalities. Anyone having at least 3.1 can follow this tutorial. So if you have like 3.0, I'm not sure you're gonna be making it. So make sure you have at least 3.1. I went so down because I wanted to give the chance to anyone to be able to follow this. So yeah, but if you have higher version, that's even perfect because you're gonna be, you know, doing great things with that. Now I want to specify which profile OpenGL is going to operate on. So you can see right here, if you have, I recommend for you guys, if you have a version greater than the 3.1 right here, if you have the 3.3, go out and put at least 3.3 here. So if you have like 4.5 and things like that, I recommend you to have at least 3.3, the version 3.3. Now in my case, I went down to 3.1. You can still leave it like that. That's not a problem. It's still gonna work. Now if you have, that's why I want to recommend you to put 3.3, because the 3.3 can actually refers to this core profile properly. So if you have a version greater than 3.3 or at least 3.3, instead of putting any profile like I did right here, you can simply go out and put OpenGL core profile. So I recommend you to do that. But you can still, as I said, leave this one. It will still works. That's not a problem. I just want you to know. So I just say any profile because I want to leave OpenGL choose what fit the most for me. So I don't want to be playing around with that. So now the last one right here is going to be if the window is going to be resizable or not. Now we can simply go ahead and create our window. So to actually create a window with GLFW, you can simply call the GLF create window. The first argument is going to be the width. The second one is going to be the height. You need a title for your window. You also want to, tell if your window should be on a specific monitor. We simply put null right here. So if you want, for example, your program to be full screen and on a specific monitor, you can do something like this. For example, GLFW get primary monitor. This will simply go on your computer and search for the primary monitor and show your windows on that. So if I run this will simply pop up. So because we don't have any loop and event handling yet, the windows will simply pop up and go. It's gonna be full screen. So if I run this, you will see we'll have a full screen window and then it's gonna get closed because we don't have any event handling yet. So we don't want to have a full screen yet. That's why we're gonna put null here. And the last argument is if you want to share this window for with another one, so anything like that. But that's not something we care about right now, so just leave that alone. So if I clean this and rebuild this, you will see a normal windows with this size that we've specified popping up on the screen, and just go. You see, that's basically it. So we also want to check if anything happened. So was the creation of the window successful? If not, you want to get the error from GLFW and show it on the screen. A way of doing that will be, for example, I would change this. I'm actually using the any profile. Let me change this to this core profile right here so that you guys can see an error message. So I want to run this and you see failed to create GLF context profile are only defined for OpenGL version 3.2. You see, because I have a 3.1 version, that's why I couldn't do that. That's why it's always important to keep things like this around, because you want to know why it didn't work, or you probably get frustrated. So make sure you always have something like that around. So let me bring this back. Okay, so now we go out and create our context, our OpenGL context on this Windows right here. If you remember, one thing that we said in the previous video is OpenGL is a specification. So it's a lot of specification of functions which then will be defined by each graphic card manufacturer. So now in order for us to actually use OpenGL, we need to actually load those functions from the graphic card and use them. But the problem is, if we want to load each function manually, then this is going to take a while. To actually fix that, there are some people who went out and built a small library called Glue, which will go and grab all the functionalities of OpenGL on our graphic card on our current computer and give it to us so that we can use them without us having to go out and grab that. So that's why we need to actually link Glue into our project to be able to do that. Now you're probably seeing that if you compile your project, this will probably not work because you don't have a Glue. And that's what we're actually going to be adding right now. Now I want to show you first where you can download Glue. So this, I'll provide the link in the description below. This is where you can come out and download it. So you can simply go and click on this link here and you will download the version you want. So this will take a couple of seconds and the download will start. So I don't want to download this again, and the process will be the same. You download, you uncompressed, and you simply copy your file in this folder right here. So you'll see we still have a lib folder which has a 64 and a 32 version. So we want simply gonna link the 32 version, and we have the static ones here. You can see it has a S, which means this is a static version. So we want to link it statically. That's why we use this. You have the includes. Normally you have includes right here. So that's basically it from this part. Now you also want to do the same process in your project. You want to go and say property, and you want to go to the C++, and there you also want to add your folder of Glue like you did for GLFW. The same thing, same process. And you also want to go to the linker, and there you want to do the same thing for in your additional directories. You want to do the same thing for the lib folder. You can see right here. And then you also want to make sure you add the lib file, the lib tag here. So that's why you can see Glue 32s. Don't forget the S because we're linking it statically. And we say lib. And one thing which is also important is to make sure you add this preprocessor, because this tell the compiler that we're linking Glue statically. So if you don't define this, your program will probably crash. Make sure you also add this by just going here and just write it. Just write Glue static. Now the compiler will know, okay, Glue is linked statically, and your program will simply run without having any problem. And make sure you include Glue before you include GLFW, because GLFW does use OpenGL functionalities in the background. We want OpenGL to operate with some modern features, but we don't actually know if our graphic card does have those modern features. So we can leave OpenGL decide that by itself. And in order for us to do that, we simply call Glue experimental and set the value to true. By setting this value to true, OpenGL will simply know for some specific task, he will simply try to use the modern way of doing it instead of using the old way. But if OpenGL does not find any modern way of doing it, he will simply go out with the default one and do the job. Now you want to initialize Glue. So this is basically how you want to initialize it. By doing this, we simply call this, and this will initialize Glue, and yeah, basically like that. And also make sure you call this after you create the context, because if the context does not exist, this will simply tell you that something was wrong. Just go out and try to do it like this, and you can see fail to initialize Glue. But if I go and make this, then you see this will properly work, you see, without no problem. The reason is you need to have a context before you initialize Glue, because you need to have a context before you grab all the function on the graphic card and operate with them. That's why it's important, this position, you need to have it after you create your context. So now we also want to define something which is also important, the viewport. So you simply say GL viewport. Now one thing I have to say is all function of OpenGL start with just GL. So you say GL generate, GL get, GL set, always start with this GL. So if you see something with GL, just know that that's an OpenGL function. And remember, all these functions were loaded with Glue. So that's why we can now use them without any problem, without any concern. You can see up here, we don't have any call of any OpenGL function because we didn't load them yet. So that's really important. So we want to set our viewport to be exactly the same thing with our screen width and screen height. This is basically like your screen right here, and this is how OpenGL does handle the coordinate system. The center of your system is in the middle of your screen. So, and basically all coordinates in system are between -1 and 1. So -1 and 1 in the X and on the Y and on the Z axis, they are between -1 and 1. Every object that is outside the range of -1 and 1 will not be drawn on the screen. OpenGL actually does that to increase the performance of your program. Everything outside of this range, -1 and 1 on the X, Y, and Z axis, will not be drawn on the screen. What we're actually doing by setting the viewport, it defines the new center of OpenGL as being the top corner, the top left corner of the screen of our window. That's why we do this right here. So now we have that in place, we can simply go and add our loop to actually make sure the windows will run forever. So GLFW, you put the window as parameter. So as long as we don't click on the red button on our window, it will keep running. So now if I just run this will basically create our windows, and I think it's gonna run. Now it's gonna stay, but we're not handling any event. That's why you see we can't do anything on the window. So to actually fix that, we need to pull the events. So we're gonna say GLFW pull events, and this will actually pull each event on the screen. I just want to finish this video for now. In the next video, we're gonna be dealing with other things. Now the last thing I'm gonna do here, GLFW swap buffer, and we say window. So this will basically handle everything we need for now. So you see we can grab our window and move it around. So just for now, what does this pull event does? This pull event actually wait for the operating system to tell the program that an event has occurred, mouse move or button or key press, or anything like that, and he will then process that depending on anything you have specified it to do. So we're gonna be adding that in the next video because this is getting too long. And this one here, I don't know if you've ever heard about double buffering. The idea is we basically have two screens, the one we're seeing and the one behind the scene. The one behind the scene, when it gets prepared, the other one is shown on the screen. And so when the one behind the scene is not ready, we will show that, and the other one will then go behind and be prepared for the next rendering. Because just having one screen which has to be rendered on the screen, it's a bad idea because you will have to wait for the update to happen before you see the result. But we don't want that. We simply want to see something on the screen, and then when the background is ready, we simply show the other one, and this gives the feelings like things is going fluently. So that's basically what this swap is doing. It's because this does use the double buffering. But we're gonna be talking more about some OpenGL stuff in the upcoming videos. So I hope you guys learn some things from this video, and if you did, please think about to hit the subscribe button, like this video, and share if you have to. And you can also support my work on Patreon. And yeah, that's all I have to say. See you in the next video. Ciao.